Oh yeah, so this is cohesion tension theory part 2, as an addendum to what we looked at earlier on. Just to reiterate what I spoke about earlier on, that cohesion is the attraction between the water molecules. That attraction is caused because of the polarity of those water molecules. Hydrogen bonds form between the hydrogen and the oxygen in different water molecules, meaning that they have a cohesive force. They're attracted to each other. With the evaporation of water from the leaf, water moves out of the xylem by osmosis to replace that water that's been evaporated here, because there's a higher water temperature in the xylem compared to this substomatal cavity. And the movement of the water out of the xylem creates a tension, a pulling force on the water molecules. Now another way, I didn't mention this earlier, but another way of thinking about that tension is like a lower pressure. Okay, because there's water is being pulled up by that tension. It's similar to, or equivalent to, a lower pressure at the top of the plant compared to the bottom of the plant. We also mentioned earlier adhesion. Now adhesion is that attraction between unlike molecules, and in this case it's the attraction between the water molecules and the molecules that make up the lignified xylem vessel walls. And it's the adhesion and that tension that can be used to explain the evidence of the cohesion tension theory. So what I've got here is a graph with the time in hours, so a 24-hour period on the x-axis, and on the two y-axes we've got two different measurements here. So in red we can see the diameter of the branch, or the diameter of the trunk, but as it says in your notes, I'll just stick to the diameter of the branch now. On the right hand side here is the transpiration rate. So the transpiration rate is shown in blue. And if we look at if we compare those two lines, we can see that as the transpiration rate increases, and we'd expect it to increase during those daylight hours where the temperature is a bit higher, as the temperature increases and as the transpiration rate increases, the diameter of the branch decreases. So this can be used as evidence. So we know that the transpiration rate is reliant on this cohesion tension theory. Part of that involves this adhesion. So during the warmer parts of the day, when the transpiration rate is at its greatest, there is more tension on these water molecules in the xylem, and in the xylem of the stem or the trunk of a tree, and in the branches. Because there's more tension, that increases the force of adhesion, or the tension from the water molecules and the xylem vessels. So that tension pulls the xylem vessels in. So with increased tension, those xylem vessels get pulled inwards. Altogether, if you accumulate all of those xylem vessels becoming very slightly narrower because of that increased tension, that's going to produce a measurable effect on the diameter of the branch or the diameter of the tree trunk. And that's exactly what we find. So during the cooler hours, where the transpiration rate is lower, the diameter of the branch or the diameter of the trunk is greater. During the warmer hours, where the transpiration rate is greater, the diameter of the branch becomes lower. This is the evidence that you may be asked for, or you may need to interpret in an exam question. Perhaps you could conduct your own experiment on this. If it's possible to find a tree, perhaps give it a hug during the day, and then go out at midnight and give it another hug. You might find that during the day you're able to get your arms all the way around, or at night, perhaps not. It's something to think about. Anyway, thanks a lot. See you later. Bye bye.